All right, these are the answers to page 716. First one here gave us this parametric equation, x equals square root of t, y equal 1 minus t. If I put 0 in for the x part, I'm going to get 0, 1, square root of 2, square root of 3, square root of 4, which is 2. For the y part, if I put 0 in, I'm going to get 1, then put 1 in, I'm going to get 0, then negative 1, negative 2, negative 3. So if I plot these, 0, 1, 0, 1 is right there. Then 1, 0 is right there. Then square root of 2, negative 1 is a little bit, not quite there, right? Just about there. Square root of 3, and then 2, negative 3 is kind of there. So we're bending kind of down, almost like a parabola. That's what we get just for those first three, heading in this direction here. Okay, so started here, headed there. That's what that looks like. If you were to keep going, this would kind of bend and keep kind of coming down like that. Now, if I wanted to eliminate the parameter, probably the easiest thing to do is try to get t by itself. So if I were to add t and subtract y, I would get t equal to 1 minus y. And then I could replace that into the other equation. So instead of x equals square root of t, I could do x equals square root of 1 minus y. All right, I can leave it like that, or I can square it, make it x squared equals 1 minus y. I could add this over, make it y equal 1 minus x squared if I wanted to. And then that would kind of fit the parabola that's coming down like this. 1 minus x squared kind of looks like that. And so we get this rectangular equation out of the parametric one from there. All right. For number 8, I went ahead and put this on the calculator, and we start here at 0, 0, and it kind of hugs and then comes up like this. So the arrows indicate what direction we're heading. We're kind of moving in this direction right there. All right, now to eliminate the parameter, this one's really goofy, and don't worry about this so much. But what I did was I just took this equation and I subtract them. So then I got on the left side x minus y. So I'm taking this minus this, and then I'm going to take this minus this, and that'll give me t squared minus t squared, which goes away, and then t minus negative t gives me 2t, which means t is equal to x minus y over 2. Now I can take x minus y over 2 and put that either in here for x, the x equation, or put it in for the y. It doesn't matter, but you just replace it. So if I did for the x, it would be x equals x minus y over 2 squared plus x minus y over 2. And now I've got an equation of just x and y. It's goofy, it's weird, but that's how I would do it. All right. 14 is a little more straightforward. Put that into the equation. You get something that looks like this right here. And again, if I gave you a full, probably be the V shape kind of on its side like that right there would be what we'd be looking at. Okay. How would I get rid of the parameter? Probably subtract 2, make y minus 2 equal to t, and then throw that in for t here. So x equals the absolute value of y minus 2 minus 1, or y minus 3. That'd probably be our easiest way to do that. And if you have y equal to the absolute value of x, you get a V-shaped graph. When it's flipped x and y, then you get that V just turned on its side. Same thing's true with parabolas. If you have y equal x squared, you get a parabola. If you do x equal y squared, you get that parabola on its side. All right, then we've got over here, x equal 2 cosine theta, y equals 6 sine theta. We get this ellipse right here. If I wanted to eliminate the parameter, what I do is I divide by 2, have x over 2 equal to cosine, divide by 6, y over 6 equals sine. And I know that cosine squared plus sine squared equals 1. So cosine squared, put that in for cosine, plus sine squared equals 1. And here's our ellipse equation. There's your vertical axis length of 2. Your horizontal axis, your horizontal axis length is 2, vertical axis length is 6. And we get the ellipse equation that you did back in pre-calc just now with a polar graph instead. For the rest of it, they just wanted you to practice putting this on your calculator. And so for 22, you should have gotten something that looked like this right here, kind of an infinity sign. 26, we should get a hyperbola. And that should make sense because we know from trigonometry that secant squared minus tangent squared is equal to 1. So this would be x squared minus y squared equal 1. There's your hyperbola opening in the x direction because x was first. So all those old things that you did from pre-calc coming back. 28 should have given you something like this. These are kind of curvy in here. So we've got this little square that forms from that. 55 gives us this little kind of cycloid, if you will, bouncing up and down off of there. 57 is similar, except that it actually bends down and loops as it goes. And then 62 gives us an ellipse that's just turned on its side like that. So that's all you were supposed to do with those.